tape is on ratio, proportion, and variation, Chapter N. A ratio is a way of comparing the relative size of two or more quantities. These may be measurements or simply numbers. When dealing with only two quantities, A and B, the ratio which compares them is A is to B or A over B as a fraction. A colon B, which means A is to B, or as a fraction, A over B. If three or more quantities are compared, for example, A, B, and C, then the ratio is A is to B is to C, and it is called a continued ratio. A is to B is to C, and it is called a continued ratio. It would take three fractions to represent the continued ratio. Absolute ratios do not carry units of measurements. Hence, both measurements should have the same units to begin with. But this is not always practical, as you will see later. If the units are different for each measurement, and sometimes they are, the unit of measurement must be carried or kept as part of the ratio. A ratio is considered simplified if, as a fraction, a over b, neither a nor b are fractions themselves, neither a nor b are decimals, and a over b is a fraction in its simplest form. For example, 3 hours is to 27 hours. This is equivalent to 3 hours is to 27 hours. Since the units of measurement are the same, then the absolute ratio representing the given ratio is 1 over 9, absolute ratio. Another example, if we have 3 1/2 hours to 20 minutes, you can see that, first of all, there are 2 different units of measurements used, and also one of the parts of the ratio is a fraction. As a fraction, this is equal to 3 1/2 hours and written on 20 minutes. But we can express this as an absolute ratio if the hours is changed to minutes in the one case, or on the other hand, change the 20 minutes to hours. We will change 3 1/2 hours to minutes. 3 1/2 hours is equal to 3 6s, 180 minutes, plus 30 is 210 minutes. So this is equivalent to, or equal to, 210 minutes over 20 minutes. We can divide out the 10 in the numerator and denominator to express it in its simplest form, and the result is 21 over 2 without the units, and consequently the ratio is shown in absolute units. Here's another example. On a map, 1 centimeter is equivalent to 10 kilometers, or 1 centimeter is to 10 kilometers as a ratio. As a fraction, we would express this as 1 centimeter over 10 kilometers. Now, it is possible to change kilometers to centimeters if we want to, because they are the same type of measurement. But it would not be a good idea to make that conversion so that the fraction is written in absolute units, because 10 kilometers would be much too large by comparison. And it's best to simply leave the ratio as I have written it with the units. Consequently, 1 centimeter over 10 kilometers is the proper way to express that. The measurements are just vastly different. Here is another example. A car travels 200 miles using 15 gallons of gas. Write this as a ratio. $200 miles over 15 gallons is the ratio that we want. Now, 200 over 15 can be simplified, and so the final ratio that we want to write is 40 miles over 3 gallons. Here, of course, because the units of measurement are not of the same type, you could not write the ratio in absolute units. If a ratio is used to increase a measurement, then the numerator of the ratio must be larger than the denominator. On the other hand, if the ratio is used to decrease a measurement or number, then the numerator must be smaller than the denominator. NUM for short for numerator must be smaller than the denominator, DEN for short, when multiplying For example, increase the speed (90 kilometers per hour) in the ratio 2 to 3. What is the new speed? To increase the speed 90 kilometers per hour, make a fraction out of the ratio and make sure the numerator is larger than the denominator. And consequently, 3 over 2 is the ratio we want to use. 3 over 2 multiplied by 90 is equal to 3 times 45, which in turn is 1,235 kilometers per hour. Another example, decrease the same initial speed in the ratio of 2 to 3. What is the new speed? If we're going to decrease 90 kilometers per hour and use the ratio 2 to 3, then the ratio must be a fraction with the numerator smaller than the denominator, which makes it 2/3. Consequently, 2/3 times 90 is equal to 2 times 30, which is equal to 60 kilometers per hour. Here's another example. A profit of $3,400 must be distributed among 4 shareholders in the ratio of 2 to 3 to 5 to 7. How much should each receive? There are 2 plus 3 plus 5 plus 7 for a total of 17 parts in all. Each person gets his share in the ratio of 2 over 17, 3 over 17, 5 over 17, and 7 over 17. Consequently, the first person gets 2/17 of $3,400. The second share is 3 over 17 of $3,400. And that's $600. Share is equal to 5/17 times $3,400, and that is equal to $1,000. And finally, the fourth share here is 7 over 17 times $3,400, and that is equal to $1,400. You will notice that if I take the sum of each person's share here, that the amount is equal to $3,400, which is what it should be. That means all of the profits have been distributed. I want to do the same problem over again, but using a different method. So here is an alternate solution. Let X in dollars represent a single share. Then 2x plus 3x plus 5x plus 7x is equal to 3,400. If we take the sum of the left-hand side here, we end up with 17x is equal to 3,400, and x equals then 200. And, of course, that represents $200. A single share is worth $200. So what does each shareholder get? First shareholder will get 2 times $200. The second shareholder will get 3 times $200. The third shareholder will get 5 times $200. And the fourth shareholder will get 7 times $200. And these amounts are $400, $600, $1,000, and finally $1,400, equivalent to the amounts found before. Next is proportion. If two fractions, each representing a ratio, are made equal, as in an equation, the result is called a proportion.